Okay, good day everyone. Og salamat sa kanunay nagsunod sa atong channel. And this time we have to discuss the plane area bounded between two curves. So I hope I can add more on what you learn through our YouTube channel. Okay, so I have the area here which is so irregular, assuming there is no formula which can be used directly to find the area because the region here is so irregular. Because if there's a formula which can be used for a common geometric figure, then there is really no need to integrate in order to find the area. So we assume that this is a very irregular region and I am considering a vertical element to find the area. So, if this is your rectangular element, so the area of which, or the dA, is equal to the length times the width. The width of this, if this is vertical, is dx. And how about the length of this rectangle? Now, we call this as y. Now, you have actually two y's. So, it touches on the upper part of your strip. So, that is why I call this as y at the upper part, or y's of u. And it is dependent on the curve you have here. So, this is your y at the upper, which is also expressed in a function of, as a function of x. The y at the lower part, I call this as yl. Okay, so this is the equation of our curve at the lower part of our element. So the length of the strip is equal to the y at the upper part minus y at the lower part. So it is a difference actually of the two ordinates. So what is the dA? The dA is the differential area, which is length times width, which is y at the upper minus y at the lower multiplied with the dx. Now, if I'm interested to get the total area, then that's the time we can introduce the integration. So I can take the summation of this differential area. So integrate both sides and the integration will be done. If this is x, so we have to look on the interval at which the region is formed. So I have to consider the abscissa of my point of intersection here, which is A, up to where? B. So this is where ang atong region na forma. So we can have the area, and this will serve as a formula if you have to use a vertical element. Now, in constructing the element, para you can only integrate once, so let your vertical strip or your rectangular element be tangent to the boundaries anywhere within the region. Okay, so that is the consideration of using the rectangular element. Now, if the horizontal strip will be used, like in the figure below. So, kining ato karong strip dire, so has a thickness of dy. Now, this is x here because this is a variable distance from the y-axis. So, this is x at the right. This is also x at the left. So, the length here is x at the right minus x at the left. And your x will be expressed later in terms of y to make it integrable. Okay, so your equation of curve mo imong basihan and your x at the right and x at the left. Now, what is the dA or what is the area of the rectangular element? Now, dA is equal to the length. And what is the length? That is x at the right minus x at the left dy. So, take the total area through integration. Integrate both sides and the integration will be done on the interval from C to D. So, these are values of y in the point of intersection because our thickness of our rectangular element is dy. Okay? So, pwede na nato magamit sa pag-integrate and this will serve as a formula for vertical strip and horizontal strip if used. So, let's consider a specific example where we are asked to find the area bounded by the curves. So, familiarization of the curve will help us trace it, no? So, tracing them, so y squared equal to 4x. If you know this, you can recall this being the equation of a parabola. So, in a parabola, it's good to locate the vertex. So the vertex is located where? Naana sa origin, and the parabola will open to the right. This is a line. So the line has the equation of 12 minus 2x. So to solve this, you have to solve first for their point of intersection. It's either I have to substitute my y here and put that into square because this is y squared. Then another option is, this is simpler compared to this, is to solve for x in terms of y diri. Okay, so what is your x? That is y squared over 4. And the y squared over 4, pwede na to i-substitute to the equation of line so that my equation will be expressed in terms of y. Okay, now, y equal to 12 minus 2, this is your x. Okay, so simplifying, 2 is reduced, or 2 is removed, and this is reduced. So that's y squared over 2, multiplying with 2, to remove this denominator, so you have y to y is equal to 24, and this is minus y squared. Rearranging the term, y squared plus 2y minus 24 equal to 0. I applied factoring, and its factor is equated to 0. I solve for y. This is my value of y, which is negative 6, and correspondingly, if your y is minus 6, then x can also be solved, which is minus 6 squared is 36 over 4, so that is 9. And how about the other factor? The 0 of this by inspection is 4. So, if this is 4 for your y, so 16 over 4 will give you x, which is 4. So, the intersection can be found where? At a point where the coordinates are 9 and negative 6. And the other point of intersection is at 4 and 4 as coordinates. You can proceed with the graph. Now, the graph of which, okay, so is presented, and the point of intersections are reflected. So you have to choose what rectangular element will be used. I mean, would it be vertical or would it be horizontal? Now, try to consider if a horizontal element is used. So anywhere within the region, the rectangular element will be touching to the two boundaries. So it's good to use a horizontal element. I will show later why it is not so good to use a vertical element. Okay, now, anywhere within the region, so the strip will be tangent to all the boundaries, the line and the parabola. Thus, it will only require one integration process to solve for the area. This is your x at the right, which is dependent on the equation of the line, and this is x at the left, which is also dependent on the equation of your parabola. Now, recalling the formula for area, which is dA equal to x at the right minus x at the left times the thickness of the strip, which is dy. Now, x at the right, what is x at the right? Then you have to integrate in order to get the total area, because integration is just like summation of all the areas of the rectangle within the region. Okay, now, x at the right is dependent on the equation of the line, which is kini. So if I'm going to solve for my x, so that's 2x, that is 12 minus y. Dividing with 2, so that is 12 minus y over 2, that is the x at the right. Because I need to express this in terms of y because the variable of integration is y. What is x at the left? If solved, we have y squared over 4, so that is x at the left. So this is in terms of y. Then consider the limits of integration, values of y where the region is formed. So it starts from where? The ordinate of my point below is minus 6 up to where? Up to 4. So it's from minus 6 up to 4. Then by calculation, you arrive with 1 to 5 over 3 square units as the answer. So just in case, no, atong ibutang ang atong strip being vertical. So you need to integrate twice or identify or subdivide your region into two parts. Because by constructing a vertical element dire, this is touching both the parabola and the line. But if you go beyond here, this will be touching on the parabola alone. So you have to subdivide this. So maybe I can call this as A1. Yeah, this can be my A2. So, there is a little delay in the process of determining the area because you have two areas or sub-areas where the area will be solved and later the two can be added to get the total area that is needed. Now, what is E1? E1, and this is a vertical element. So, by formula ganina, so we say it is y at the upper minus y at the lower times the dx. Okay, so integrate to have the summation of all these areas. So we have E1 which is equal to, what is y at the upper? The upper part of your element is the line. And its equation is 12 minus 2x. Sabutan ni mo de. Minus, what is y at the lower? So this is a parabola. And there is an upper branch and a lower branch. Right? So originally, the equation is y squared equal to 4x. So if you extract the square root, there is plus and minus. So meaning, mauni ang imuhang upper part which is the positive 2 square root of x and the lower part is the negative 2 square root of x for your y, or your y equal to a negative 2 square root of x, because when we take the square root, we have the plus and minus value. So the upper part is the positive, the lower branch is the negative. Okay? So, we substitute minus the lower, which is the negative 2 square root of x. So, we integrate that with x. So, the limit of integration must be considered. At what interval E1 is actually formed? It is from where? So, you look at the coordinates of the point of intersection. You have to start from 4 up to where? Up to 9. So, the limits of integration can be seen from the graph. Okay? So, evaluating, we come up with a value which is 61 over 3 square units for your A1. A2, so you need also to determine your A2. I put my figure inside a rectangle because this figure is a parabolic segment. We can also avoid integration if we know the area of a parabolic segment, and the formula of which is equal to 2/3 of the area of the circumscribing rectangle. From the dimension, because this is having a coordinates of 4, 4, so meaning this is 4 here, and this is also 4 going here, and that's also 4 there because it is symmetrical when this is the axis of your parabola. So this is equal to 8, and that is 4. So we have 2/3 of 8 by 4, and that is 64 over 3 square units as your A2. So you can add the 2 to get the total area. Or another way of solving for the area A2 is really by integration. If either the formula for the parabolic segment is maybe somewhat forgotten, so we can also do the integration. So constructing a rectangular element here, so from the x-axis, muna itong tawagon og y. So by symmetry, this is also y here. So this is actually 2y, correct? So area A2, so the area, differential area E2 is equal to length, which is 2y, multiplied with the dx. So what is really A2? Putting your constant outside, so the area is formed with a value of x from 0 to 4 as limits of integration. What is your y? If this is the y that is considered, so it is equal to 2 square root of x. Okay, so dx, so by calculation, you have 21.33, which is also 64 over 3 square units. So the total area can be solved, which is the sum of E1 and A2. That's 1 to 5 over 3 square units. So this is the process of finding the area of a regular region or through integration. Another example, just for familiarization, say we are given and we are required here a first quadrant area if it's bounded by a cubical curve and a parabola. Okay? So first, you always have to consider the point of intersection. Now this is 2y and this is y. Okay, so if this is 2y and this is y, so pwede siguro ang second equation ni mo sa nakon 2y. If I'm going to multiply that with 2, so my second equation will also be 2y, which is twice, that is 8x. That is also minus 2x squared. So if this is 2y, that's 2y, I can equate the 2y's equation. So x cubed is equal to 8x minus 2x squared. This is a polynomial equation with a degree of 3. I can arrange them in descending manner. X cubed plus 2x squared minus 8x equal to 0. So, I can remove x by factoring. So, I have x squared plus 2x minus 8. Okay, and I can factor out my x. So, the other expression, if factored out, I obtain this one as factors. So, I have three values of x. One is 0. The other is 2. The other is x equal to minus 4. And correspondingly, I can solve for my y. Okay, this is simpler. If my x is 0, then y is also 0. If my x is 2, so that is 8 over 2, that is 4. If my x is equal to minus 4 cube, that is minus 64, correct? And you divide it by 2, so that's minus 32. But, kini siya, while this is also a point of intersection, but this point belongs to what? Quadrant. This belongs to quadrant number 3. So, what we need is only a region that's found in quadrant number 1. So, di na nato ni apilon. So, kinira mo ito ang point of intersection that we may be interested. So, point of intersection is at 0, 0 and 2, 4 when our consideration is quadrant number 1. This is my graph. So, for the parabola, before tracing, so it's good also to recall on how to trace a parabola by reducing it into its standard form. We usually have to arrange the term, no? Gadong quadratic na to nga variable, so will be placed on the left. So, the expression, because in a parabola, so only one of the variable is in second degree, the other variable is in first degree. So, gadong nasa second degree will be placed at the left. This is the standard form. The parabola here may open upward when it is plus here or downward when it is negative. Okay, rearranging my term. X squared minus 4x. My y is placed at the right. So, produce a perfect square trinomial because this is a binomial square. Good if this is 1. So, I can just consider half of this coefficient, divide this by 2 which is minus 2, and take the square. You are inserting a term here, a term which is 4, so we can also add the same term on the other side of our equality symbol. This is added with a negative 2 squared or simply 4. Binomial square, x minus 2, that is in square, and by factoring out the negative 1, so we have y minus, this is positive 4, so this becomes negative 4 also. The vertex is found where? It's k. This is my h. 2, my k is 4. This is negative, it means it will form downward. So, with the vertex and what else? So, vertex of your parabola and the point of intersection we have, then I can now proceed with my graph. Okay? So, here we have the graph. 0, 0. What else? And 2, 4. So, meaning, ang ato dieng unsa, two curves are actually intersecting right at the vertex of our parabola here. Okay? So, this is 0, 0 and 2, 4. So, this is now the graph. Okay? This is for the cubical curve with this as my equation. And my parabola that opens downward has the equation of y equal to 4x minus x squared. Now, looking on the graph, so, if this is clearly defined y in terms of x, so it's good to use also a vertical element para in reducing your y in terms of x, so there is no problem really to reduce your equation y in terms of x. So, construct a vertical element, and it's also good because our strip will be tangent to the two boundaries anywhere within the region. Okay, what is your dA? The dA is equal to y at the upper, or the parabola, minus y of the y of the cubical curve on the lower part times the dx. Limits of integration. If you do the integration, so it is formed, or the region is formed with a value of x from 0 to where? To 2. Because this is dx. Okay, so 0 to 2 as limit. So, upper is the 4x minus x squared. make it x because the variable of integration is x. Okay? So 4x minus x squared. Okay? So minus x cubed over 2. So, by the way, you can insert here a grouping symbol, no? Okay, before you integrate, especially when you are using a calculator. Okay, so the grouping symbol here actually defines the term in the upper y and the lower y. Then, mao na itong integrand, so it's good to place a grouping symbol dire. You may have a bracket. Okay? Then, by calculation, this will give us 10 over 3 square units as the answer. So, thank you. And I'm happy to share to you, no, on how to find the of area of a region which is bounded between two curves. So thank you for watching, and I'm inviting for those who are new in my channel to subscribe. Nya kadtong mga karaan na dire. So isir-sir sa uban, no? So I know nga napay daghang interesado ini o wala lang siguro katultol pa asa ato ang channel. Okay? So thank you for watching, and I'm very glad that you're always around watching and supporting my channel. Thank you and good day. Thank you and bye-bye.